Alright, so here we go with Lesson 6EE2, Day 1. So first we're going to talk about how to translate phrases into expressions. So some key terms that we need to be aware of. So sum, remember that's the answer to an addition problem. And difference, product, quotient, those are all answers to the different problems. So the answer to division, answer to multiplication, and difference is answer to subtraction. And then we need to know that a numeric expression is a math sentence that just has numbers and operations. But then now we have algebraic expressions that have not only numbers and operations, but it's also going to include letters. It's going to include variables. So I remember this by thinking of the alphabet being part of the algebraic expression. And then, of course, variable. So a variable is a letter that can stand in place of a number that can change or is unknown. All right. So these are some key terms here, keeping in mind that anytime that we see sum or difference, that's going to imply to us that we're probably going to need some parentheses inside of our expression. Quotient and product possibly could mean that, but sum and difference for sure. Alright, so here we're going to take a look at the problem. We have write the algebraic expression for the product of y squared and 5. So now the difference here is that we have included variables. So the idea is still the same. You're still looking for those terms that are helping you understand, or that are telling you what operation you're using and so on and so forth. So here I have y is an important number because, well, it's a variable, so it's representing a number we don't know. And squared is going to be an operation term. And this is where we have to remember our words from exponents. So squared means that we're taking something to to the second power, so 2 as an exponent, and 5. And then I also have product, which means I'm going to multiply. So I want the product, I want the answer to y, and I want that y squared times 5. So my algebraic expression would be y squared times 5. Alright, so again, we're going to write the algebraic expression. Again, if you want to try this on your own and come back and check your work, that would be great. Otherwise, stick with me. We'll go through some more. So here I have 3 times the sum of negative 6 and b. So I want 3 times the sum of negative 6 and b. So here, this tells me I want 3 times the answer to the addition problem. So in order to make that answer to the addition problem happen first, and that addition problem, in this case, so the sum of negative 6 plus b. So I want the answer to this, and I want to multiply it by 3. So I would take 3 times. Now if I just write negative 6 plus b, that would not make me multiply 3 times the answer to this. Okay? It would actually make me do 3 times the negative 6. So in order to make sure that I do that that addition first, since that's not the case with PEMDAS, I would put parentheses around my negative 6 plus b. Now what's going to happen is I'm going to find the answer to this addition problem, and then I'm going to multiply it by 3. Alright, so write the algebraic expression for 7 less than the difference of negative y and 12. So 7 less than. Now remember, I told you previously that less than is really important. It tells us that we're going to actually switch up the order of our numbers. So even though 7 comes first, 7 is what's being taken away. So I want 7 less than the difference of negative y and 12. So I want the difference, and I want 7 less than that. So I want whatever the answer is to this question, and I want 7 less than that. So I want to take 7 away from that. In this case, I want the difference of negative y and 12. So what I'm going to do is I'm going to put my negative y minus 12, and then I'm going to do minus 7. Now, previously we had said that difference means that you're going to need parentheses. And I said almost always means you need parentheses. Here, what I would do, though, is I would put this y, negative y in parentheses to show that it's a negative and not a subtraction sign. That just is something that helps us visually with what the number actually is. Okay, but here I don't need parentheses to make sure that this part happens first, because according to the order of operations, we have subtraction and addition, and they work their way from left to right. So since this one comes first, this would happen, and then we would do the second subtraction. All right, so 1/2 the difference of a number and 22 plus another number, all plus negative 12. So in this case, 1/2 is an important number. Now, a lot of times we like to think of 1/2 as dividing something by 2. However, if it's giving us, if it tells you, well, I want half of this, in word problems, typically that would mean that we could divide by 2. But in this case, I want 1/2 the difference. So 1/2 in itself is actually a number. And remember, dividing by 2, we talked about this when we were working with dividing fractions. So dividing by 2, I'm sorry, that's a half. That is very different. Dividing by, maybe if I could actually click on eraser, there we go. Dividing by 2 is the same thing as multiplying by its reciprocal, which is 1/2. Okay, sometimes you might see 1/2 of the difference, and of reminds us to multiply. But a lot of times when you see a fraction like this and they say, oh, I want 1/2 or I want 3/4 the difference, 3/4 the sum, it's telling you to multiply. All right, so I want 1/2 the difference of a number, so that tells me I don't know the number, and 22 plus, now here's the thing, another number, all plus negative 12. All right, so here's the thing. I want 1/2 of the difference. Okay, and the difference in this case is the difference between a number, and I'm going to just choose x, and 22. So I want 1/2 of this. So I'm going to put the difference inside of parentheses to make sure that it happens first. And then I have my 1/2 on the outside of that. Whenever you have a number connected to parentheses, that means multiplication. So now I have 1/2 the difference of a number and 22 plus another number. Okay, so I actually got a little bit ahead of myself here. There we go. Since there's no comma here, we have to look at this all as one group of stuff. So I want 1/2 the difference of a number and 22 plus another number. So when it says plus another number, that means we have to choose a different number that we don't know. So I can't use x again. So here I used x. Since this is another one, I have to use a different variable. So I'm going to use, let's use q. That seems like a letter that doesn't get used a lot. Okay, so now I want 1/2 the difference plus another number. So I have that all, and then I have this comma in here too. So I want all of that plus a negative 12. And again, I put the negative 12 in parentheses, so I know that this negative sign goes with the 12. Right? So keep in mind, if I want all of this plus negative 12, all of this is going to happen before I add the negative 12, according to the order of operations. So I don't have to put the rest of this inside of parentheses. Okay, so 1/2 times the difference plus another number all plus negative 12. And as time goes on, these become a little bit easier, and you'll be able to do them a little bit more quickly. It's really just a matter of reading and following the problem and looking for key words like difference and another number, or the fact that you're looking for fractions or sum, things like that. Alright, so here we have 13 more than the product of a negative number and the difference of 12 and 6 divided by 10. So again, I have that comma in there, so that tells me that that's going to be a separate step. So I have 13 more than, so 13 more than the product. So I'm going to have the product of whatever numbers I'm multiplying together, because that's what product means, that I want the answer to a multiplication problem. And then I want 13 more than that. So product then add 13. And that product is a negative number. So this time I'm going to use n. And the difference of 12 and 6. Okay, so I want a negative number. So negative means that n is going to be negative. Times, but I want to times by the difference. So I'm going to have some parentheses in here, and I'm doing 12 minus 6. Alright, so far, that's what I have. Then I want to divide by 10. Okay, so I want negative n times the difference of 12 and 6. So far, so good. And then I want 13 more than that. Once I'm done with that, that's what this comma tells me. Once I'm done with that, I want to divide by 10. But here's the thing. I want all of this to happen before I divide by 10. This addition won't happen before I divide by 10. So this is where I do need to add that second set of parentheses to make sure that I am able to do my difference times my negative, add, and then be able to divide. So my problem would be negative n times 12 minus 6. That'll be in parentheses. So that way after I do 12 minus 6, I can multiply by negative n. Then I'll add that 13. And after all is said and done, I will divide by 10. Last but not least, so I have 18 plus a number cubed times the difference of negative 13 and a different number. I would like you to try this one on your own and then come back and check your answer. So I have 18 plus a number, so I don't know what the number is, so I'm going to assign it a variable right away, and I'm going to go with n, cubed times the difference of negative 13 and a different number. So again, this number can't be n, it has to be something else, so I'm going to make it x. So 18 plus a number cubed, so that n is going to be cubed, which means it's taken to the third power. Here's a comma, so then I want to multiply that by the difference. So if I want the difference to happen first, we know that means I have to have parentheses, of negative 13 and a different number. So that's where that x comes in. But now here's the thing. I want all of this times all of this. So in order to make this addition happen before that multiplication, this part in the front would have to go in parentheses as well. And then I can put the multiplication sign in there if I want, or I could just connect them using parentheses. But your answer should look like this, and it'll have parentheses in the front and parentheses at the back.